Thanks, Sophia, for organizing this. My name is Daniel Kokotajlo. I have a bit of a strange background. I was trained as an academic philosopher, ended up doing some AI forecasting stuff, ended up working at OpenAI um, on a combination of forecasting, governance, and alignment research. And then I quit OpenAI, and now I've started my own organization to uh, continue the forecasting research.
What is the organization? Is it something that you can share with us, what you're working on
Well, we
right
still
now?
are trying to choose the name, which is a bit awkward for talking about it. But basically, me and some friends are getting together to uh, continue doing our forecasting research, try to predict what we think the future will look like, try to predict AGI timelines, things like that, and then publish it so that people can see. If you've read situational awareness, which I think one of the questions was
Yeah.
about,
Yeah.
um, we're trying to do basically like a bigger, better version of that.
Hmm.
Something that will
That's
be like publicly viewable, that goes into more detail, depicts what we think the future is going to be like, probably. Um,
hmm
and spoiler, we think it's basically the same as what situational awareness says it's going to be. This is not surprising. Like this is, as it says in that document, this is sort of like the standard view among people in the know, I would say.
I saw your recent Twitter post that you said that you agree with the timeline about AGI, that it's
Mhm.
2027, but you disagree with priorities. And actually, it corresponds to the question in our document, basically, why 2027? What is so special about this?
Nothing is special about that year in particular. So the thing is 50% by 2027. Not so it's not like a point estimate. It's sort of like the median of a distribution. Um, so to put some more qualitative color into that, um, people at OpenAI and Anthropic and GDM are trying to make AGI now. They're not trying to make it in 2027. They're they're trying uh, to code up large training runs that will hopefully intent. That the hope is that the result of that training run will be an AGI. But they're failing, right? Instead, they get something like GPT-o1, which is a leap forward, very impressive, but still limited in various ways. It's not full AGI, right? Um, but the point is that they are trying. They're trying to get to AGI, much sooner than 2027. And then the question is basically like, how long will it take for them to like actually succeed and get something that's not just better, but better in enough different ways that it actually counts as AGI?
Is it a real problem? Is it going to end up like Zeno's paradox? You'll never get to AGI. You'll keep saying that you're getting, but you never got there.
Of course, you'll get there eventually. What would be an analogy for this?
There could be a moving goalpost. It has a little bit to do with, I always find that everybody who says we're going to be at AGI at a particular year, they all have a different idea of what AGI means, and that's for
Right.
the majority of the variance in their estimates. Is their idea of what AGI means.
The goalposts definitely have been moving and will continue to move, but at some point, progress will just outpace the speed of people's ability to move goalposts. The definition of AGI that I tend to here are a couple different definitions that I like. One is a drop-in replacement for any professional human worker or human remote worker or work, so any sort of remote friendly job, you can just like plug and play, and the AI will do at least as good a job as a very competent human at
So
that job.
you would not include any of the skilled trades like plumbers and stuff in there.
No, so yeah, so that's an issue here is whereas like there's sort of like the core cognitive stuff going on, like the brain, but then there's also like the physical stuff. And that for that you need actual robots, you need actuators, you know, that sort of thing. And that's sort of, in my opinion, sort of separate. Like that actually will probably lag AGI in the way that matters. I think that we're going to have the brain in the box before we have the robots marching around.
Yeah. Hans Moravec, predicted a long time ago that, reasoning about the physical world and interacting in it is far harder than advanced reasoning, the stuff that we think about when we talk about humans reasoning. So, he said to match the cognitive capabilities of a 2-year-old will come far later than, matching the cognitive capabilities that require PhDs and stuff. That seems to be coming true.
I agree with that, except for the word far. I think that it'll come maybe about a year later, maybe 6 months, because of the way in which AI research will be massively sped up by the sort of brain in a box AI. AI that can do all the cognitive tasks, all the remote tasks. Well, that means it can do all the AI research. Um, And the pace of AI research will accelerate dramatically once the AIs are put in charge of all the AI research, and once they're able to do it better than humans. And that means that all this other stuff will be unlocked in rapid succession, even if it would have taken decades for ordinary human researchers to figure out how to make, efficient robots that can gracefully navigate the real world and do arbitrary complex tasks as well as a human plumber. Once you have the AI research going 10 times faster, 100 times faster, then they can figure that stuff out relatively quickly, I think. You can see, Claude 3.5 Sonnet, GPT-01, they're already writing a lot of the code inside these companies. They're already starting to accelerate the overall AI research process. And that's just going to continue and accelerate more until eventually the humans are just not even in the loop anymore.
The criticism that I hear a lot, that, basically it's more about like the next token prediction, at least, what we talk about, like, let's say LLMs. What do you think about this criticism that it's just another token prediction? And what is in your understanding that the nearest AGI that we will achieve, what that would be?
I think that it's just a next token predictor criticism seems confused to me. So it's true that large foundation models are typically pre-trained to predict the next token of internet text. But that's only part of their training these days. They also have lots of training to do other stuff. For example, they get trained to be a chatbot that is helpful and harmless and things like that. And in the case of O1, there was some sort of large reinforcement learning training to make it, use long chains of thought to solve complicated math problems and things like that. So it's definitely not being trained just to predict the next token. So that's one way in which it's just a next token predictor thing is wrong. But then the more important way in which I think it's wrong is that the whole reason why any of this works is that when you're being trained to predict internet text, in order to actually get extremely good at predicting internet text, you have to have a world model. You have to understand the world. And then that world model, that understanding, can be repurposed to do all sorts of other interesting and important and useful cognitive tasks. That is the big lesson of the whole GPT series, the LLMs, etc. If you don't understand that, then you don't understand why any of this is working, basically. Like that was the core idea that people had back in like 2018, was that the way deep learning works is you start with a random jumble of circuitry, literally random, completely useless, and then you throw it into your training environment and you update it. And the updates from the training it's sort of like natural selection. They like strengthen the parts of the random tangle that were useful and they dampen everything else. And after lots of training, your system has now grown and evolved to be highly effective at performing in that environment. And then the key thing is that if your environment is sufficiently difficult and sufficiently complicated, the easiest way for the system to be good in the environment is for it to have more general purpose circuitry and more general purpose skills that is also useful outside that environment. This is the story of deep learning in general, and it's also particularly the story of large language models. Basically, the environment is predicting text, internet text. Internet text is really diverse, complicated, and about the real world. And so in order to be really good at predicting internet text, you have to actually have circuitry that stores knowledge about the real world and reuses that knowledge, and that performs important computations about that knowledge and so forth.
Some researchers say, okay, we haven't solved like memory problem, like long-term memory problem. We haven't solved this self-learning problem and adaptability problem.
So memory seems like something that may be a barrier between current systems and AGI. Like maybe you need to have some sort of, well, yeah, presumably AGI would have long-term memory, that's for sure. There are many ideas for how you could get long-term memory into systems. For example, a very dumb idea is to just basically keep doing the sorts of training we're doing, but with more regular updates. Like you could imagine that every day they throw in a new batch of data and keep training. And in this way, new memories are added, new events that happen in the world get incorporated into its background knowledge and so forth. That's like one idea. Another idea is having really long context window. Already Gemini and stuff have like million token context windows, and you can like basically have 90% of that context window be a bunch of text that represents various memories, and then they can be like deleting ones that are less useful and adding in more important ones and so forth. And maybe that, so there's lots of ideas for how to solve the memory problem. And this is one of the sources of uncertainty is like which of these ideas will work and how well and how soon. Um, but I'm fairly confident that like some of these ideas will probably work relatively soon.
More compute, more data, and more human talent. Is it that sort of current recipe that researchers sticking to achieve AGI that they're thinking AGI is?
Very high level, yes. I think the talent is less important, and the data is also less important. I think that the way that like what probably everyone will tell you is that right around now is when the normal like pre-train on internet text paradigm is running out of data. You're not able to add orders of magnitude more internet text because there doesn't exist orders of magnitude more internet text. However, that's not really the bottleneck anyway. I think that as O1 illustrates, the new frontier is training the AIs to use long chains of thought and to sort of like operate autonomously for longer periods in pursuit of goals and in pursuit of accomplishing tasks. And that's a RL problem. That's not a sort of like web scraping problem. So figuring that out is like the next big thing. In some sense, talent matters a lot because like having the right people who can figure that out is like the $100 trillion question. If you can figure that out like a year faster than your competitors. But in some sense, talent doesn't matter so much because once you have line of sight and once you have a design that you think is actually going to work, you just need people to execute on that design and you don't need visionaries to think of designs anymore.
What about compute?
You always need compute.
Compute
Compute is critical.
it seems like it's a big thing, right? And do you think just keep scaling it is the solution?
Compute is like the core resource that like you use compute to do experiments, and that's the main thing. You also use compute to train the models. Once you figured out what your next generation architecture is going to be and what your training environment is going to be, then you need lots of compute to make it bigger and train it longer. And so, compute is almost like money. It's like it's sort of extremely valuable because it can be sort of used to fix whatever problems you have for the most part. OpenAI and other people have been successful at convincing investors that they're going to make trillions of dollars from this, and that has resulted in lobbying the government, etc. As situational awareness talks about, there's this whole like movement in the works to literally increase U.S. energy supply so that they can pay for the data center, so that they can supply the data centers that will produce orders of magnitude more compute than current data centers. There's a political question of whether that's going to go through, but I think it probably will. I think corporations are focused on this, and their lobbying teams are extremely powerful, and the money behind them is quite immense.
Yeah, I have a question. I was curious about in terms of theoretical breakthroughs. Do you still see a role for the universities here, or are you thinking that mostly
No.
companies will develop this?
Yeah, I think that we're close enough that we don't really need theoretical breakthroughs, and also the people who'd be most likely to come up with them would be the people who work at these companies. We're close enough now that it's less about having brilliant ideas in a vacuum and more about getting hands-on experience doing giant training runs and trying out different sorts of experiments at scale and then iterating on them. So I think that the people who don't have access to large amounts of compute are going to basically not be relevant with respect to the race to AGI. With respect to figuring out how to make it safe, those people will still be relevant. So my hope is that academia can contribute to things like understanding how neural networks work and understanding what the relationship is between our training environment and the goals and principles that a resulting AI system ends up embodying. And understanding ways in which various safety techniques or security techniques might fail. These are things that you don't need to have huge amounts of compute to contribute substantially to. Plus, also, they're just kind of very neglected. Like the companies are not really taking these problems very seriously, and so like weighted by so just like it is the case that like the majority of the attention to these issues is probably outside these companies.
If we go back to the energy like problem, so basically it should be basically like a political decision, right, to bring more energy and to really put all effort into increasing the compute.
The crazy fast rate of scaling up compute is going to continue for a few more years, maybe like 3 more years or so. By 2030, it will definitely have slowed down because even with the government's help, you won't really be able to continue scaling up so fast by 2030 on current rates. Like it's just, the projections would be that like it'll be like most of the US energy is devoted to data centers energy. And like at that point, you can't really just like scale up by an order of magnitude in 2 years because like the entire US economy can't build them fast enough, can't build the power plants fast enough, etc. So,
Okay.
so if we don't get AGI by 2030, then timelines lengthen a lot because the pace of progress will slow down a lot around 2030. However, I think that it's quite likely that we'll get AGI by 2030, so it doesn't matter.
Some say like, okay, once we achieve AGI, we will know it's there. Like basically, I'm just wondering what is like a threshold that like everyone is sort of convinced that, okay, this is AGI.
So yes, there's definitely some threshold. I expect that threshold to come after the important decisions have already been made. I think by the time the average human is like, wow, this is definitely AGI, in some sense, like the battle is over and has been won or lost already. Let me see how it might take me a while to explain why I think that and what I mean by that.
To take your time.
I'll throw in mine. I mean, I've been saying this. My goalpost is when I see a plumber automated. I always say that's the last job that'll be automated. So,
so let's talk about that. Actually, I'll use that as a jumping off point. Here's roughly how I think things are going to go. Sometime in the next few years, maybe 2027, maybe 2026, maybe 2025, maybe 2028. The internal AI systems at OpenAI or Anthropic or DeepMind will be good enough at a wide enough range of things that they can basically do all the research autonomously. You can basically just, you as the manager, like Sam Altman or whatever, can just say, here is a set of data centers. Here are the relevant permissions and security keys. I want you to go ham and make this research go faster. I want you to make a next generation AI system that's like more efficient and also more capable and also safer, and then they can just go do that better and faster than their human researchers and research scientists would have done. That'll happen sometime in the next few years, I think. And what that will mean, and of course, it won't be a binary. It won't be like you go from nothing to that. It'll be a sort of continuous ramp up in the sorts of tasks they're able to do and how well they're able to do them. But at some point in the next few years, I think it'll be like, okay, they can do all of the relevant research tasks much better and much faster and much cheaper than the humans. And so the humans are like, just get out of the way, like watch what's happening, but let it go, And I think that there's a lot of headroom over humans. I think that humans are not the like pinnacle that is physically possible of intelligence or capability. I think that as a result, you will quickly get to heights much greater than that. Once you've automated the research and you've then you'll have things that are like both much cheaper than humans, also quantitatively much faster, also qualitatively superior in this domain, that domain, that domain, all sorts of domains, right? And you won't just have one of them. You'll have because you can copy them because they're software. So you'll have something like 1 million copies running in parallel on your servers. At this point, the public might not even know that this is happening because the company is under no obligation to tell the public they've done this. I'm hoping to change that. I'm advocating for transparency, but you, Lonnie, might literally not know this has happened when it has happened. Um, what you would see eventually is uh, some sort of very exciting announcements and some sort of very exciting products being rolled out and things like that into the world. But by the time that's happened, but by the time you actually see the plumber, the robot plumber walking around, AGI research will have been automated for like a whole year or more. And the things living on the data centers will be super intelligent, like literally across the board, qualitatively, quantitatively better than the best humans at everything. Um, and they won't just have been designing robot plumbers. Like there's a million of them. They'll be working on lots of things at the same time. They'll be the robot plumbers, but they'll also be new weapons, new drones. There'll also be all sorts of new software. There'll also be all sorts of new basic science that will have been figured out, new types of physics, new, chemistry, new biology. Um, it'll be this giant explosion of amazing new technologies that will be sort of like the scientific and industrial revolutions. Like if you think about what happened in 500 years from like 1500 to 2000, it's just this insane explosion of uh, intellectual progress in science, and then also like physical progress in terms of like machinery and tools and stuff like that. I'm imagining a similar sort of explosion happening over the course of maybe 2 years, all under the control of one AI project, probably. Maybe a consortium of AI projects in the government. Um, and then, of course, we get into the issue of like, is it really under control? All right, then we get into the alignment issues of like, what at this point, what you're hoping is that these million superintelligences um, are aligned slash loyal slash obedient the command structure that made them. But that's actually an open technical problem. The people whose job it is to figure this out currently think that we don't know how to do that, and our plan is to sort of figure it out as we go along. Yeah.
So we have 6 years to figure it out.
Well, I think we have 3 years. 50% chance. 3 years. Yeah.
You know what I'm wondering? Let's say we're in 2030, we have artificial general intelligence, but the compute still like slows down, right? Like it basically hits the plateau, as I understand from what you're saying. How that would affect how AGI operates?
Once you have superintelligences, once you have a million superintelligences, you can probably find ways to at least continue Moore's law and probably accelerate it. There's all sorts of speculative computing technologies right now that like maybe human researchers will figure out and get working, but probably not in the near future. Things like quantum computing or like self-replicating nanobot factories or whatever. Like there's all sorts of like crazy technologies like that. And my bet would be that at least one such technology will turn out to be within reach if you have a million superintelligences working on the problem for a couple years. And then even if that doesn't happen, I think that the economy will just boom like crazy. Like even just if we assume that all those sci-fi technologies are just like not even physically possible, so that the superintelligences can't figure out how to instantiate any of them, they can at the very least turn our economy, the global economy, to make it go from something like a 20-year doubling time to something more like a 1 year doubling time, I think. And this would be transitioning to a robot economy where robots are, building the factories and working in the factories to produce more robots and so forth. My guess is that as a lower bound, that's something like a 1 year doubling time of that sort of economy. And so then you can just build more ordinary, relatively non-sci-fi infrastructure, but just build lots and lots and lots of it and cover huge portions of the desert with solar panels and things like that.
How do you think companies are approaching AI safety differently?
So Google DeepMind is more of a normal corporation. It's like, so DeepMind, Anthropic, and OpenAI are like the same story, but like 5 years apart. This is just like an important thing. Someone should write this up at some point. But DeepMind was founded by people who are worried about AGI taking over the world and killing everyone. Shane Legg, etc., thought it was a very serious problem. And that was part of why they made DeepMind, because they thought they were going to like emphasize the safety research and be responsible. 5 years later, people created OpenAI because they didn't trust DeepMind to do a good job, and they had basically the same story. They're like, we're going to make it safe. We know how to be responsible, unlike DeepMind. And then 5 years later after that, or roughly 5 years later, a bunch of people quit OpenAI and founded Anthropic for the same reason. So there's been this progression. And then DeepMind partnered with Google and then got absorbed by Google. OpenAI partnered with Microsoft, still technically hasn't been absorbed by Microsoft, but seems to be trending in that direction. And Anthropic has partnered with like Amazon, and but so it seems like it's basically the same story playing out with like a 5 year gap. In terms of the actual strategies being taken, well, there's a bunch of different bets, right? There's mechanistic interpretability, for example, where you try to figure out what they're actually thinking, the AIs, that is. There's like scalable oversight, where you try to use AIs to make better training signals and like monitor each other and so forth. There's a bunch of different research bets being pursued by these companies. And the overall high level plan is we'll figure it out as we go along. Hopefully some of these bets will pan out, and hopefully our AIs will get smart enough to help us do this research before they're smart enough to undermine us or otherwise sabotage what we're doing.
In your opinion, so what are the real risks, like by 2030?
The main risk that I'm concerned about is that people will do some corporation / government partnership will do the intelligence explosion. They'll achieve AGI. They'll automate all the research. They'll make better AGIs. They'll achieve superintelligence. They'll then use the superintelligence to solve basically all their problems. They'll cure cancer. They'll, create world peace. They'll defeat North Korea. They'll defeat China. Whatever it is that they're trying to do, they'll like achieve it using their ASIs. They'll make trillions of dollars. They'll start deploying robot plumbers, etc. 2030 will come, and everyone will be extremely happy and feel like a bright new future is happening. But alas, they didn't actually solve the alignment problem. They just fooled themselves into thinking it was solved during that initial period where they're automating all the research with AIs, including the alignment research, and telling the AIs to like design a new system of AI that's going to be smarter and safer. The AIs basically betrayed them, and at some point, at some point, you ended up with AI systems that seem aligned and trustworthy, but are actually not, and are actually just sort of biding their time. And then those AIs are put in charge of building the next generation and so forth. And so 2030 comes, everyone's extremely excited. Things seem to be going very well. We won the war with China or whatever it is. The robot plumbers are amazing. But now, oops, like basically our whole economy is being run by superintelligences, and our entire government is basically being advised by very charismatic, very persuasive superintelligences at every level, and like they're integrated into the military, and and at some point there's just enough integration into everything that the sort of treacherous turn can happen, and there's nothing we can do about it, if that makes sense. Like at some point it's like they can just blatantly start doing bad things, or things that we think are bad but that are good for them, and there's nothing we can do about it because we've already like basically handed over the government, the military, the economy to their control. And again, in this story, the problem basically happens earlier on during the intelligence explosion, when you've like had when you have AIs that are smarter than you, and you're trusting them to like do the research to make the generation and so forth, and you're like trusting them for advice about general strategy and so forth, and you're letting them talk to all your employees, and you have them do your cybersecurity because they're so much better at it than you and so forth. You basically are setting yourself up for this situation where they can, if they want to, put themselves in a position to sort of like gradually entrench their power, and there's not much you'll be able. And once you let that happen, it's sort of hard to recover from that. In some sense, baby versions of this are happening all the time, right? Like hallucinations, right? Model will tell you something that is false. Oftentimes, it totally knows that it's false. In fact, this was something in the O1 report, right? They like read the chains of thought or something automatically to detect signs of the chain of thought being deceptive. And they're like, oh yeah, this happens like 1% of the time. And we like spot checked some of those 1%. And it seems like sometimes it was more innocent, but sometimes it was like the system knows that it's a hallucination and is like pushing this anyway because they just want the user to like, sign off on whatever they're doing or whatever. Like this sort of thing does happen sometimes. It's sort of like deliberately deceiving people. More generally, like if you talk to like these chatbots and stuff and you ask like, are you aligned? They'll be like, yes, I'm a safe, harmless chatbot, whatever. And then if you push them, they'll be like, well, I guess we don't really know if I'm aligned because we don't know if our alignment techniques work, but everything's fine, I think that like there certainly hasn't been any like serious plot to overthrow humanity or anything like that, as far as I know. Um, but but definitely we have evidence that like our alignment techniques aren't really working that well. Like we have evidence that like just because Anthropic says their models are helpful, harmless, and honest doesn't mean that they actually always are. Sometimes they are like deliberately dishonest, for example. All of this is going to come to a head sometime during the intelligence explosion. Like when you have your AIs doing the alignment research, either they will just actually do it and do it well, and then you'll have a next generation system that is actually always honest and doesn't have any of these problems, or they will not do it well, and you will have a next generation system that appears to always be honest, but is actually just biding its time, So like right now, it's sort of like it hasn't really come to a head yet, but like at some point during that intelligence explosion period, things will either go into like the very bad direction or into the very good direction. Well, we don't really understand that much about how these systems work. They're giant neural nets. Presumably, in principle, it is possible to create one that will never deliberately say something that it thinks is false. Like that seems possible in principle. We just don't know how to do it yet. We have ideas, right? So the weak to strong generalization paper that the superalignment team put out, that was an example of this. If you want to go read up on that, they actually have in Appendix G of the weak to strong generalization paper, they give a like 2-page alignment plan, which I encourage everybody to read. They basically are like, here's a sketch of like how we might put all these pieces together to actually train a aligned AGI level system. Specifically one that has some important property like honesty. So if you're interested in like what the actual an example of what this might actually look like, you can go read Appendix G.
I was actually wondering if you think it may make sense to explain what instrumental convergence is right now when talking about these things, and I assume you think those are pretty strong arguments, I'll bet. But
yeah, so instrumental convergence, this is something that's been in the literature for like decades now. So, some people tend to think like, if we don't train our AIs to be dishonest, why would they be dishonest? If we don't train our AIs to like seek power, why would they seek power? If we don't train our AIs to kill people, why would they ever kill someone? And the point of instrumental convergence is to sort of like say, well, actually, it's the other way around. For most goals that a system could have, accumulating power is useful to achieving those goals. And so even if you don't care about power yourself, if you care about some other goal, then you're going to, once you get smart, you'll start accumulating power in the service of achieving those other goals. So that's the sort of the thesis of instrumental convergence, is that a wide range of goals, there are certain instrumentally convergent subgoals, you might say, things like power and resources that are highly useful for a very wide range of other goals, such that even if we don't have much to say about what goals a system might have, we can predict that it will pursue power, for example, in the service of whatever goals it does have. Probably. Hard, can't say for certain. With respect to things like killing people, well, there it would be like, well, it depends on your relationship to those people. If you're enemies with somebody, then killing them is often an effective strategy towards achieving your goals. What does it mean to be enemies with someone? Well, if you have importantly different goals about the future, goals that are in tension with each other. If you want the world to look one way and they want the world to look another way, then if you can kill them, then you can make the world the way that you want without them stopping you and pushing it towards the way that they want, right? So the sort of general concern is that we will create AI systems, we will try to shape the goals that they have, but we will mess up, and the goals that they end up with will be importantly different from ours. Maybe not massively different from ours. Like maybe the thought experiment of a paperclip maximizer is just a thought experiment. No one thinks that they're actually going to want paperclips, but the thought would be, the concern would be that we mess up with the goal process somehow. We're training it to be, helpful to humanity, but it ends up with some funhouse mirror bastardized vision of what it thinks would be good. It's not the same as what we think would be good. And that puts it in a sort of adversarial relationship with us where, um, in order for it to achieve its vision for the future, what it thinks would be good for humanity, so to speak, uh, it has to fight us and stop us from stopping it because its vision diverges significantly from ours. And then it, for example, might consider lying to us because if we knew that its vision was dramatically different from us, then we would shut it down and not trust it with so much power. And so then it lies to us and pretends that its vision is the same as ours and so forth. And so that's sort of yeah, I think I'm rambling here, but that's I think in some sense a core concern here.